So in this problem, we need to find the area of the shaded region, or we're looking for this bit of area here. So immediately, I'm thinking, okay, what if I found the area of, say, this triangle, and found the area of this complete sector, subtracting from each other, and what's left is going to be the area shaded. So that's where I'm thinking I want to go. That's my plan of attack. So first thing I need to do is I need to set up some sort of ratio. I know that the area of a circle is equal to pi times the radius squared. And so that tells me that area equals pi times 24 squared. And so I'm going to go 24 squared is 576, so area equals 576 pi. This is for the whole circle. Okay, so how about this? We set us up a ratio to figure out the area of this sector. And by that I mean the sector in here. 360 degrees in a circle over 576 pi equals 120 degrees over x. Let's not call it x though. Let's call it a sub s for area of the sector. So a little cross multiplication, and we'll have a sub s times 360 degrees equals 120 degrees times 576 pi. All right. Notice our answer, we're leaving everything in terms of pi, so we're not going to mess with multiplying pi out. So that tells me that a sub s equals 120 degrees times 576 pi over 360. Okay, so now let's keep going on and see what we can come up with as far as the area goes. Move this out of the way. We'll get 120 times 576 equals 69,120. Divide that by 360. And area of the sector equals 192 pi. Okay. So that's the area of our sector. So now what we have to do is we just need to figure out the area of the triangle. And by the area of the triangle, I mean this area. So what do we know? How do you find the area of a triangle? Area equals 1/2 base times height. So what we need to do is we need a couple of things here. We need to know how tall this triangle is. Right here, here's our height. And we need to know our base. All right, well, if we cut that in half, if we cut this, make a perpendicular bisector, we know we've got a right triangle. That's 90 degrees. This guy, cutting this in half, becomes 60 degrees. So it looks like we got a 30, 60, 90. Okay, so how does that help? That's right. We got special properties of right triangles. And just a quick review of some right triangle trig, which was done last year. If you have an equilateral triangle, say that we make this not 60, but remember this is equilateral, so each angle is 60. Let's call this 2 and 2 and 2. And then we can divide the triangle in half. This 2 is now 1, and that's 1, right? Oh, that's 30, and this is 30. And then we said, nope, that's not 30, that's 60. This is 30. That's 30, that's 60, 90, and 90. All right, so what did we say last year? We said that our height, well, let's do a little Pythagorean theorem to talk about it. We know that a squared plus b squared equals c squared, and we have an a squared, which we'll call 1, and 1 squared is 1, and plus b squared is going to be 4. And if we subtract 1 from both sides, we get b squared equals 3, so b equals the square root of 3. So we said that we always have this ratio, right? And let me erase some of this, or actually, let me erase all of it. Make it a little bit better, a little easier to see. Equilateral triangle, 1, 1, 2, 2. This side is the square root of 3. Okay, and that is saying that this is a right angle. This is a 60 degree. This is a 30 degree. All right, so how does that help us? Well, I'm not quite sure. Actually, I am sure. If this is 12, or if this is 24, that's going to correspond to, oh no, I don't want to change it. That's going to correspond to, well, look, we got a 90 degree angle here. So it's going to be half. That means that this guy right here is actually 12. And this side right in here is going to be 12 times the square root of 3. Okay? So let's just redraw that right here so that we can see it. 24, 12, square root, 12 times the square root of 3. All right, so all we got to do is find the area of this triangle. So 1/2 base times height. And we have, well, let's see, what do we have? 1/2 the base, which would be half of 12 square root 3 is 6 square root 3 times 12 equals 36 square root, that's wrong, let's try 72. 72 square roots of 3. Okay, so this is 72 square roots 3. That's 72 square roots of 3. So that means total area we have is 1/2 base times height. I'm sorry, that's not right. Not 1/2 base times height. We have 72 square roots of 3 here, 72 square roots of 3. So we have a total of 144 square roots of 3. That's the red triangle. All right, so what we said we had to do is take the area of the sector, which we found to be right here, and subtract it from 144 square roots of 3. So I'm looking at B. Fun, huh? All right, all right.